go.
Okay, so y'all can take notes if you want. You don't have to. It's not mandatory, but whenever you want. Okay, so this is our lesson.
How the ocean affects our weather.
Yeah. Oh, the objective is for y'all to learn how the ocean affects our weather. Like we just said. Okay. Okay, so we're just going to call on people to read the slides. Either half of the slide or all of the slide. Okay, so call on someone.
Maya.
The oceans affect temperature majorly because without the ocean, our temperatures would be extreme. The ocean is heated by the sun, and that turns into water vapor, which increases temperature. When it is much colder, air over the continent flows outward toward the ocean.
Okay, the climate. Who wants to read the climate? Now we have a lot of hands. Okay.
Redistribute heat to the whole globe. It moves bodies of warm and cold water everywhere. The currents flow in complex patterns as affected by them.
Okay. Now the atmospheric pressure, which is fronts. Who wants to read that? Maya, you've already got it. Okay. Avery, choose someone.
Ryan.
Fronts.
I don't care who.
Fronts are affected by the oceans. There are warm fronts. It is the surface boundary between a warm air mass and a cold air mass. There are cold fronts. It separates a cold, dry air mass from a warm air mass. There are how do you say that?
Included.
Occluded fronts. It forms when a cold front catches up to a warm front. There are stationary fronts. It is the boundary between two different air masses.
Okay, now we have a video.
Oh, we do?
Wait.
Yeah, we have like 3 videos.
It's like awesome.
Oh, hold on.
So, yes,
So are we in a cold front right now?
pretty much yes.
Snow Day! Oh, RJ, watch it. Sorry, I'm a little excited for our random day off.
I can't believe there was a snowstorm. It just came out of nowhere.
The snow didn't just come from nowhere. A cold front moved in.
A what?
A cold front? A front is the boundary where two air masses clash, and weather, like snow, occurs. There are warm and cold fronts. I'll demonstrate.
No, don't. Just tell me.
I'm not gonna throw it at you. Listen, you know what an air mass is, right?
A big massive blob of air?
Kinda. An air mass is a large body of air that has the same temperature and moisture level throughout. There are 4 different types of air masses in the United States, and each one carries its own temperature and amount of moisture.
So what are their names?
Well, 2 are cold and 2 are warm. The 2 cold air masses are the maritime polar air mass and the continental polar air mass.
What about the 2 warm air masses?
The 2 warm air masses are called the maritime tropical air mass and the continental tropical air mass.
So which ones can I thank for the snow day?
It snowed because one of the cold air masses clashed with a warm one and made a cold front. When that snowball hit you, it exploded, right?
Yeah, and it hurt.
Well, Sam, I think it's instant replay time. Let's say the snowball was a cold air mass, and you were a warm air mass. When you both clashed together, a front was made, and the ball burst. It snowed.
Oh, that's kind of cool.
Yeah, this snowstorm is a result of a cold front. Cold fronts happen when a cold air mass pushes a warm air mass up. Big puffy clouds, called cumulus clouds, are formed. When you see dark clouds like those, you can bet you're in for some heavy rain, thunderstorms, or a snowstorm like this.
What happens at a warm front?
A warm front happens when a warm air mass catches up with a cold air mass and slowly climbs up and over it. As the warm air mass passes over the cold air, long, thin stratus clouds stretch out across the sky. A warm front can cause rain and snow too, but it's light and steady, not heavy and stormy like a cold front's weather.
So, a cold front means pretty crazy weather that gets me a snow day. And a warm front just means it might still rain or snow, but it won't be as intense. An air mass is a large body of air that has the same temperature and moisture throughout, and there are 4 types of air masses in the U.S. Each one has unique characteristics that hint at where it formed. When 2 of these air masses meet, they form a boundary called a front. It can be a warm front or a cold front, but either way, some kind of weather always happens on a front.
Hey! Okay, I deserved it. It's freezing though. I think I'm gonna head in for some hot chocolate.
Man, that RJ was cool.
What? Does that mean I'm not?
You said it, not me.
You can just close this. Okay, so this is about hurricanes. Who wants to read? Someone who hasn't read.
Brian and Josh.
Destiny.
Hurricanes can only form over oceans where there is warm seawater and land. Without warm salt water, hurricanes would never be a thing or ever exist. Once hurricanes move away from warm water and move over to the cold water, the hurricane will start to die.
Okay, there's another video.
Violent winds, driving rain, killer waves. These are the hallmarks of a hurricane. Also called cyclones or typhoons, hurricanes are giant storms prowling the world's tropical seas. An average hurricane releases as much energy in a day as the explosion of 500,000 small atomic bombs. Hurricanes form in the summer and fall when the sun heats vast stretches of tropical ocean to over 82 degrees. Warm, moist air rises over these hot spots, creating thunderstorms. Upper-level winds and surface winds then come together, forming a circular pattern of clouds known as a tropical depression. When the winds exceed 39 miles per hour, a tropical storm has developed. When the winds reach 74 miles per hour, a hurricane is officially born. Inside the storm, bands of rain up to 300 miles long meet in the eye wall, the most violent section. Here, winds of up to 200 miles per hour spiral upward. Within the center of the hurricane, downdrafts of dry air create a strangely calm area called the eye. Fully formed, a hurricane may stretch over 500 miles in diameter. That's a storm nearly the size of Texas and reach a height of 9 miles. Most of these storms spin out over the open sea, but in an average year, 2 or 3 will strike the mainland of North America. And when they do, the damage can be catastrophic. Most dangerous is the storm surge, a wall of water that sweeps across the coastline where a hurricane makes landfall. About 45,000 people were killed by hurricanes in the 20th century, including some 15,000 in the United States. Hurricanes are also costly in dollars. 1992's Hurricane Andrew was the most expensive natural disaster in U.S. history, causing more than $25 billion worth of damage. Scientists are searching for better ways to predict the path of a hurricane. Special planes called hurricane hunters fly directly into these monster storms and drop sensors to measure wind speed, temperature, and air pressure, providing vital clues to the hurricane's direction. New 3D models are also helping scientists understand this awesome force of nature and provide quicker and more accurate warnings to anyone unlucky enough to be caught in its path.
for the best subscription offers to any National Geographic magazine. Log on to nationalgeographic.com/magazines.
So wait a minute.
Yes.
So hurricanes will not form near any cold water.
No.
So they will only form in what? Where do we mostly see them?
The tropic.
Indian. The Indian Ocean.
Pacific.
The Pacific and where?
Indian.
Do they form in the Indian
That's the
Ocean?
warmest ocean.
The Indian Ocean is?
Yes, ma'am.
Near the Indian and Atlantic.
The Indian and the Atlantic form the most hurricanes?
Definitely in the Arctic, though.
Yeah, not happening there.
Okay. So
Okay.
this is El Nino. So one person is gonna read up until here, and then Avery, call on someone who has read.
Josh.
El Nino causes very intense weather in many places because of the southern oscillation. The southern oscillation is a change in the atmospheric pressure amidst a high pressure system of South America's coast and a low pressure system near Indonesia and Australia.
Okay, who else wants to read?
Lauren.
In North America, there are more tornadoes and heavy rains. In Indonesia and Australia, there are more fires and droughts. In Peru, there is more flooding.
Okay, this is about La Nina. Okay. So who hasn't read? Okay, Ryan hasn't read.
La Nina is pretty much the opposite of El Nino. Instead of places being super hot, they are instead below average in temperature. In Africa, things are drier. In Asia, there are tropical storms. In North America, there is below average records of rainfall.
Okay, now there's another video. What? Oh no, we're gonna do like strings.
Yeah.
It was a basketball.
El Nino. We all know that in Spanish it means the Nino.
El Nino!
But what is El Nino? What about La Nina? What do they mean? I'm meteorologist Jason Myers, and El Nino and La Nina are both complex weather patterns that alter the entire weather landscape around the world. El Nino and La Nina are opposite phases of what's called the El Nino Southern Oscillation, or ENSO cycle. Both take place in the east-central equatorial Pacific Ocean. In other words, off the coast of South America. During an El Nino year, there's an upwelling of warmer water off the coast of South America, and in a La Nina year, there's an upwelling of colder water. This difference in ocean temperatures then alter the weather around the world. Since oceans cover roughly 75% of the planet, they play a big part in our weather patterns. So when we see a big temperature swing over a large section of the ocean, it changes weather patterns worldwide. For the United States, an El Nino event will typically bring a warmer, drier winter to the northern half of the United States, while the southern half of the U.S. gets a colder, wetter winter. A La Nina will typically bring dry, warm winter weather to the southern U.S. and slightly wetter and cooler conditions to parts of the northern U.S. between the months of December and January. Both events, however, have very little effect on the United States weather in the summer. And one last thing. It's called El Nino because these events usually show up around Christmas time, and the South American fishermen who first discovered this was occurring called it the Christ Child, El Nino. Thanks for watching the video. Don't forget to like it, subscribe to the channel, and comment below.
He's a real YouTuber. He said hit the like button.
Okay, these are our sites, you know. Okay. So again, you can close.
Wonderful.
Okay. Zach, would you like to read the summary? Okay.
We are teaching about how the ocean affects the weather of our day-to-day lives. There are many ways the ocean affects the weather. For instance, we get increased temperature from the ocean. We also get hurricanes through the ocean and El Nino and La Nina. These are all very extreme weather patterns. Hurricanes are formed through warm salt water or the ocean. And without the ocean, hurricanes and cyclones wouldn't exist. El Nino and La Nina are also extreme weather patterns, and depending on where you are in the world, determines how El Nino and La Nina affect you periodically. You can have dry weather with El Nino or wet weather with La Nina, and neither extreme is preferable. In conclusion, the ocean affects many parts of the weather.
Okay. So we have a few hands-on activities. Okay. So first there's the turn, which Avery would like to demonstrate. Okay. So, we used to do this as kids, and then you spin the bottle, and then it makes a little hurricane or cyclone or whatever you want to call it. Okay, so now.
So how did it say that hurricanes are formed?
Through thunderstorms over the Atlantic and Indian Ocean and stuff.
And then wind passes over it and turns into a circular.
Okay, so now we're going to do the El Nino experiment. Okay, so, yes, I would like you to move so I can. Okay, so what we're going to do is we're going to break you up into your groups, like the second one and the third group. So go ahead and do that. Okay, so what we're gonna do is we're gonna need more mineral oil, and we're gonna pour the mineral oil over the water.
So you guys are gonna demonstrate it first, and then they're gonna get their materials.
Yes. So we're gonna pour the mineral oil over, and then you're probably gonna need to fill it 2 times so that it covers the whole surface. And then, wow, knife in my face. And then you're just, okay, and then you're just gonna, make sure it's fully covered. And then you're gonna take the blow dryer.
What is the, okay.
Yes. Oil and smoke.
What is the oil acting as?
The warmer water, and then the ocean's the cooler water.
The blue's the cooler water underneath. Okay.
Okay, so.
And we're demonstrating El Nino or La Nina?
El Nino.
Okay, do you want to go get the towels so that, things don't spill everywhere? Oh, beautiful. Thank you. Okay, and so then we have a map under here to show, like Australia and just where El Nino occurs. So go ahead. You can, wow, I was expecting those. Okay, go ahead.
So this is demonstrating what?
Oh, are you asking us or the class?
I'm asking you.
Oh, it's pretty much demonstrating how, stop squirting me, how the currents, she's purposely trying to do it, how the currents are, moving, how the water's moving, and how, it affects everywhere.
So in El Nino, which is what we're doing.
Yes.
It's like upwelling.
There's an upwelling of warm water
over the cold water.
going to where?
The different places. The stars. Hey, Grace.
Like
What
different
place?
sections, like-
There's difference, like
Yes. It's going
towards south.
Yeah, towards South America.
So the
and
warm
then-
water's coming towards the top.
Yes.
Okay. And in La Nina,
It's going towards South America and it's vice versa.
the cold water's on top.
Yeah.
Mm-hmm.
What causes, because naturally the warm water goes where? Where does warm water or warm air go?
To the top.
To the top. So why in this instance does the warm water go to the bottom?
Anyway, would you like to explain?
I don't know.
Okay, so it's pretty much like because of the ocean currents and stuff, it moves the water around, and so that's why it's, you know, on the bottom instead of the top. Okay, so y'all can come up here and I don't know.
Oh wait, we need first name dressing water.
Okay, so for the water, well, there's instructions over here. We're super fancy. Okay, so you take the water and you fill it within an inch of the top.
Which one's the other one?
Oh, okay. Oh, okay. No, it isn't. No, it isn't. Okay, you can stop now. And then we just add some food coloring. And then do you want to stir? Okay. Do you want more?
Sure.
Wait, I have a question. Are
Yeah.
there supposed to be 2 groups?
Yes, you can do it over here too. Okay. Now add cinnamon oil.
Let's go over. Script them. Make it even.
You can just do the rest of it. You can use the knife and just cut it. What? You don't have to do the food coloring. It just shows you which one is which.
Okay.
Okay, now turn on.
Sorry.
You're fine. Okay, the way you supervise this. I'm just gonna stand up because.
But you just stirred. Let Ryan do it.
Well.
Let Ryan.
Do you know how to operate?
Yes, I do.
Did you do it?
It's not my fault.
You want me to do it?
Yes. It's too difficult.
Good job, Maya. It's there
Fine,
for
you
you.
gotta aim over there.
Oh.
No, you gotta let them do it.
Okay.
Don't get too close.
So the wind from the hair dryer is the current, the wind current, pushing the warm water that's on top towards the land, which in turn warms the ocean, which warms the air, air. And when the air is warm, there tends to be